these are some of the exams questions under indices and logarithms. So this is a pure indices questions. So let's have a look at how to solve this type of questions. But before you solve any indices question, you have to make sure that you know the exact tools that you have to use in solving the problems, right? So maybe some of the things that can convey you to your destination, those are the things that you have to have at your disposal. So let's have a look at the first one. So the first law of indices says that if you are multiplying and then the bases are the same, then what you have to do is to add what? The exponent. So what it means, I have a very nice beautiful diagram here that says that, let's say this is a car, right? This is a truck that loads up some goods. So the truck here brings up a load on the day one. So this is the first day, and then the second day the same truck, right? You can see a very nice image here. So the same truck also bring another goods on the second day. So this is the first day and the second day, but you can see that we are dealing with the same truck. What happened? So if that is the case, assuming we are multiplying, this is just an assumption, right? Assuming there's a multiplication between the two track, right? So the day one and the day two. So what I have to do, since the track is the same track that brought these goods yesterday, and then today the same track brings these goods here. So what I have to do is that we just need to combine their goods, right? Just it's the same track that brought the goods here. Can you see that? So you just need to combine the two goods. This happens when we are multiplying, right? So what I mean by that is that, assuming the law of indices are if the basis, so this is what we call a basis, exponent something being multiplied by what? Another point, then exponent 2. I will say that this is what I mean by the same track here, right? So the same track, you have to make sure that you are seeing the same number here before you can add the two. If the numbers are different, you can never add the two. Is that okay? So what happened? This will give you the same track and then s of plus 2. That is fine. So what will happen if here, suppose here is 9. So what can you see? So I can see that you are not having the same track here, right? You are not having the same track here. So what you have to do, you have to make sure that you rewrite this thing to suit this number here. You have to make sure that you are seeing the same track. So of course this thing can be what? 3 exponent 2, right? So 3 exponent 2, that should be what? That should be 9. So that is for the first point. Is that okay? So the second law says that if there's the same track, right, with the same scenario, if the track they are being divided, right, there's a division sign between the track, right? So this is the same track with this good, and then and the second day you have that track with this type of goods here or load, right? It's being divided. This is just an assumption. Understanding people, what happened? So you have to subtract the loads that they brought, right? So that's the side of subtracting that away. And then the latter part of this law under indices says that, maybe let's say if you have equal sign between the track, right, the same track with this load, and then they say it's equal to, the meaning of equal to is that whatever is here has to be the same here. Of course the track is the same, right? The same track here, the same track here. So what happens is that the load also has to be the same, since this is equal sign. So what this thing simply means that if you have 2 exponent s here is equal to 2 exponent 1, have you seen that the track are already the same? If the track are already, it means that the goods are also the same, so meaning that s is equal to 1, right? So these are some of the 3 conquered law or the tools that you have to have at your hand to tackle almost all the questions under indices. So let's have a look at some examples or exams questions and see how directly or indirectly we can apply this type of law. So here's the first question. The question says that we should find the value of x. Find the value of x if that 8 exponent x is equal to 2 the root of 2, right? So 2 multiplied by root of 2. So we should find this x. And this is a pure indices question because a number being raised to a certain variable, right? So that is what a pure indices question. So what do we know? We know 3 different rules, right? 3 different tools that we have at our disposal. So which one can we use here? Of course, I will say that this is the third one. The third one, according to my diagram. So this is the third one. Since it's being equal, there's an equal sign here. All I have to do is I have to make sure that you are seeing the same number here, right? Raised to a certain power, then we can just equate the load, right? So look at this base. Even this guy is not being raised into any power, right? It's not being raised into, here's 8 and the numbers are not the same. So it's your duty to manipulate these two numbers to be the same. Then at that point, then you can just equate what the exponent. So how do you do that? Here I can see that there's a 2 here, right? Have you see here there's a 2 here, then here is 8. But here this 2 here, you have to make sure that you are seeing the same 2 here. So in the case of the scenario, this is just the track, so the first track. This, of course, the trick here is that you have to make sure that you are dealing with what the smallest number, right? The smallest. You cannot rewrite this thing to become 8. Rather, this guy can what come down to 2. So that is the trick here. Now I know that there's a problem here, so just have a look at that. 2 exponent 2 can never be what, can never be 8, so there's a problem here. This should be what, 2 exponent or 3. Is that okay? So let's correct that. So here should be what, 2 exponent 3. 2 exponent 3 will give you what, 8. Can you see? I'm just dealing with this 8 here. So 2 exponent 3 will give you what, 8. So the idea of indices is that you have to make sure that you have a ways of rewriting the numbers to suit what you know. So we know these 3 rules. So the first rule, or maybe the third one that we are dealing with, so that's the 3 exponent 2. 3 exponent 3 here will give you what, 8. We are not doing anything to the x. So let's look at this guy here. What is happening to this guy, right? So there's a square root sign. Look at this square root here. This square root is the same as square root of 2, right? Square of 2, or maybe square root of 2 is the same as what, 2 raised to the power 1 over 2. This 1 over 2 is the same, is the vice versa of this square root here, right? It's just the vice versa of this square root here. Is that okay? The 1 over 2 is the same as 1 over, so I can rewrite just this part here to be what, this guy, right? So 2 multiplied by 2 exponent of 1 over 2. This square root sign here tends to be what, 1 over 2, right? Okay, now then we are just manipulating the numbers here. So what happened here? So from this point, you can see that this 2 exponent 3 will give you what, 8, as we saw already. So this 3 is multiplying. Let me see, these are the loads, right? There's one load here, another load here. So let's combine them. So with this bracket tells you that they are multiplying. So that one gives me what, 2 raised to the power 3 exponent of x here. So what is happening at the right hand side here? Look at what's on here. Obviously that this 2 here is multiplying, right? So that is what we had. This 2 is being multiplied by whatever is here. After we rewrite this guy to be what, 2 exponents 1 over 2, we have 2 outside. So 2 is also multiplied whatever is here. So that's how I got 2 being multiplied by 2 exponents of 1 over 2. We are not doing anything. We are just rewriting what the number is what in that order. Why are we doing all these things? For us to know or use what we've already known, right? We know that if the bases are the same, then we can just equate what the exponents, right? The load, right? It's the same track that brought the goal, so we can just add the goals all together. So what is happening here? We don't have any issue again, but look at it. Look at this guy. They are multiplying. Can you see? They are multiplying. So I know one law. So that's the first law, that if the track are the same and then they are multiplying, what do? You just add the exponent here, right? So what are the load? The load here, the first load is 1, the second one is 1 over 2, right? So that is very, very simple here. So we are just add the two goals, as I was playing at the beginning of the video. So now we got to this point. Have you see? We have the same track here. The same track here is being equated. So the two guys are equal, meaning they are the same. So if they are the same, then what I have to do, you just need to equate the exponent, right? So that's how I got 3x here. So you can see that since the bases are the same, right? The bases are the same, meaning they are having the same track, right? So since the bases are the same, you can just equate the exponent. So that gives me 3s is equal to 1 plus 1 over 2. You have to solve this here. You just need to find the LCM, right? And do your thing there. Then you arrive at 3s is equal to 3 over 2, meaning that your x will give you 1 over 2, right? If you are finding it difficult, you may comment down below, whereby we can take to your disposal. Okay, now let's look at the second question. From this question, you have been asked to find this guy, right? This guy. So what's the name of this guy? This guy is 3 exponent x. So this is what they're asking her to find, being given this. They say if that if this 3 exponents minus 1 is equal to what? Y, they say you should find this 3s, right? So this is just a very simple question, direct question. Then we are giving this, so all I have to do is I have to make sure that you have something like 3 exponent s is equal to what? Another thing over here. So meaning that we are looking for this guy, right? And this is what we are having. This is what we are having. So what can you do? You can just rewrite this thing. So look at the trick here. The trick here is that when you have something raised to the power minus 1 over 2, so let's have a look at that. So let's say I'm having 3 exponents. This is what we are having, right? This is what we are having. Here, this guy here, we can just rewrite this guy to be what? 1 over what? 3x. Is that okay? You can just rewrite that to be what? 1 over 3x. So what do you think if I have let's say 3 exponent minus 2s? What do you think this guy will be? You see, always there's a minus here. Just turn this minus to be what? To be something like 1, right? 1 on top here. Is that okay? So that's just the simple trick. So when you have something like this, so 3 minus 2s can be equal to, you can rewrite this thing to be 1 over 3 exponent of 2x. So just turn this minus here to be 1 on top. Okay, so this is how simple you can rewrite this type of problem here. Okay, now back to our question. Then you can see that you're having that guy to be what? 3 exponent minus s is equal to y. Then what I have to do, you just need to rewrite this guy, right? So that is how I got what? My 1 over what? In indices, all I have to do, you just have to rewrite, manipulate the numbers to suit something that you already know or that they are asking you to find. So what are they asking you to look for? They are asking you to find this guy, right? Now obviously that we can find a 3 exponent s here. So what I have to do, you just have to make this guy stand out here. And then how do you make this guy stand out here? So you can see that this guy will multiply that. So that's how I got on 1 to be equal to 3s multiplied by y here, right? So here as at this point we can divide here by y so that this guy will stand alone. So how about 1 over y to be equal to what? 3 exponent of x, right? So that is how simple you can solve this question, meaning that 3 exponent x is equal to 1 over y, right? So that is very simple. So now here comes the third question, and let's see another trick here. In this question, our target here is that they say you should find the value of n, right? They say you should find n, but look at what is happening. This guy is being equal to this guy. So what we know is that once the number here and the number here are the same, you can just equate what? The exponent. That is something that we know. But look at this guy here. Earlier in this video, or maybe in the first question, we saw that when I have something like this, square root of 2 can be equal to 2 raised to the power 1 over 2, right? So that is one trick. Is that okay? We are just rewriting the square root sign to be what? 1 over 2. Okay, you can check these things to see if you are having the same answer, right? So what will happen if you have a number here? So we call it this is 3, right? So cubic root of what? 2 exponent of 2, right? So if here is 4, that is the 4th root of what? Look at this 3 is not multiplying. The 3 is hidden under or inside this square root sign. Can you see that? So how do you do that? If you have 2, square root of 2 is equal to 2 raised to the power 1 over 2. Then this guy here, if there's a 3 here, this 3 here will just go under what? This side. If here is 4, here should also be 4, and so on and so forth. Is that okay? So that is how simple you have to understand this. Okay, now back to our question. So what are we having? We are having 16 exponent is equal to what? The cubic root of what? 2 exponent 2. So my first step is that I'm not doing anything to this guy. So I just will write that one, the guy here. So under the square root sign, we are having 2 raised to the power 2. So this cubic root here will then be 1 over 3, right? 1 over 3. Okay. Now our aim is to make sure that the numbers here are the same, right? So look at what is happening. I'm having 16 exponent n here. So this 2 square in the bracket here will give me 4, right? We are not doing anything to the outside. So if you decided to leave these 2 and convert, or you try and see whether you can get 2 out of the 16, I don't think you will get a number that 2
will raise to certain power will give you what? A 16. There's no number. 3 will give me 8, and then 4 will give me what? Something different. Is that okay? So our aim is to make sure that the numbers are equal. Okay, so I decided to multiply that or square that. That gives me 4, and then 60 exponent n. Okay, what happens? So out of the 16 exponent n, I can see that I can have 4 there, right? I can have 4. So 4 square will give me more 16. Is that okay? Meaning 4 square here is just what? 4 multiplied by 4, right? 4 multiplied by 4, that is equal to 16. Is that okay? Alright, so it's the same 16. I'm just rewriting the number. So we are not doing anything to the outside. So 4 exponent to 4 exponent to all brackets multiply by what? Or all exponent what? N. Okay, so on the right hand side we are having 4 exponent what? 1 over 3. So boom, we are getting to what? Where we are supposed to be. Is that okay? So we consider the 2 here is multiplying what? The n. That's how I got my 2 exponent. N is equal to what? 4 raised to the power 1 over 3. Obviously, this is the main reason why we are suffering. We just want the numbers here to be equal, right? Meaning that it's the same track law that brought the goods, and there's an equal sign between them. What happens that if this guy is equal to that, then it means that these two are also equal. Is that okay? So meaning that we have 2n is equal to 1 over 3. Right? 1 over 3. So you solve for n here, meaning that you use this 3 to multiply whatever is here. That gives you 6, n is equal to 1. So you divide both sides by what? 6, and that will give you what? N is equal to 1 over 1 over 2. So this is how simple you use some of these tools in solving this type of question. If you've enjoyed this video, don't forget to subscribe to our YouTube channel for more content like this. So thank you for watching.